we're just doing the Rust book thingy. Okay. So far we're this is a long page. Okay. Here I guess. Okay, so here. Now I'll have you remember. Step down you show note that the code doesn't comply just yet. Will it explain? As ordering. Okay, match the guess. So guess is this. Unused variable again. So this is the guess, and we have to compare it, right? Yeah. First we doesn't use name. See ordering. Now when the root consider importing one of these. Oh, CMP. The CMP, the CMP, sorry. Okay, so this is gonna say unused import one by default. Okay, so we have a secret number. Let's print this here. So I'll print a new line and say here the secret number is, and then here you say secret secret number. Okay. And then we have to match the guess. So it says here right there. If it's less than okay, ordering. Okay, you take okay, first add the number use case. As for the scope, okay, I did that. The ordering type is another enum that has a variant less and equal three outcomes that are possible when you compare two values. Yeah, so basically in JavaScript that would be the same function as like the sort, or like what sort takes, which which returns a like minus 1 0 or 1 to match. Okay. Then the let's out again impossible. Then we add 5 new lines at the bottom ordering. The method compares two values that can be called, that can be that can be called on anything that can make it takes reference whatever ordering in them. We create into scope this statement. We see same reverse scope. Okay, the match comparison expression decide what to do next on the variant. On the variant. So to ordering was recall a match expression is made up of arms. An arm consists of a pattern matching against and the code that should be run if value given to a match fits the arm pattern. Rest takes the value given to match and looks through each arm in the pattern, pattern, and match the construct a powerful Rust feature lets you express a various expression encounter take full advantage. Chapter 6 or chapter 18. How many chapters? 21. Oh, wait. Oh, the appendix. So 20 chapters. Freaking hell. I'm in chapter 2. Okay, it's fine. Let's walk through an example to use this. It does say the user guess is 50 and then when it's 60. When the there's a 50, you can message will return greater because 50 is greater than the match gets the expression gets the order in greater value. Start checking each arm pattern. It looks like the first arm last sees the value and does not match the last, so it ignores the code on the arm. And next arm, the next arm is greater, it just match, it associates the code is the arm and executes prints to be to the skin machine, so it won't look less arm. However, types Rust has strong static type system. However, it also has type inference. When we wrote that machine Thirst was able to infer that guess should be a string, that doesn't make sense. It doesn't make it doesn't make us write the type. The secret number on the other hand is a number type. If you also basically it's saying that this is an end and an integer 32 and 32 bit, but this one is a string, right? Okay. So you cannot compare. So if we do the code, so match, guess, compare, match the guess, the compare, and it takes a reference, right? So it takes a reference to the secret number, and then, oh, sorry, that's not dot, just match guess. Take it, take, and then we just say ordering. Okay. There's a different uh, greater, and then it returns a function. I believe you can do this as well. This is in the show, but greater means too big, and then equal less is, yeah, so you can do anything. It's basically like a switch statement, but different. Doesn't have like a breaking point unless it breaks. Okay. So too small. And here we can equal. We can say oh sorry, this is println, I think. Yeah. So I want to. Mm. So this is basically a macro, from my understanding. Is a macro that belongs to the output in each call. Within a hot loop, this behavior may be bottleneck. If loop to avoid this bottleneck is cd out lock. Okay, so I macro basically inlines it if I'm not mistaken, but I'm not very sure. Alright, anyways. You one. Okay, so this is not great. So secret is a number, but guess is a string. But so if we run this, so cargo run. Alright, so first of all, it says here unused import. Unused import. Am I not importing this correctly? So the tutorial doesn't say that. So let me just copy this. Uh, no, it still says. Okay, I guess I. Ah, that was weird. Anyways. Here we go. Mismatch type, inference of string, and if found integer. I'm going to incorrect. Okay, so when I let me cancel that and do another run. Method time definition says here commented method are incorrect. Expected a string but found an integer. Okay, so that's good. Now let's see. Okay, here we go. So the correct error says that the main fetch type plus has strong static type. However, it also has some inference rewrote. Let me see string. Ross was able to infer to guess that it should be a new string and didn't make us write the secret number. On the other hand, the number type is a Rust type that can be value 1 to 100. Uh, 1 to 100 because we did the rand to 1 to 100. So this to 1 to 100. But it's an integer 32, so it has like 2 to the power of 32 bit representation. So it can represent that many numbers, or like this minus 1, I guess, because of 0. Anyways, I64 is the 64 word number as well as other, unless otherwise specified. Rust returns which is the type of a secret number unless you added a type information elsewhere that would Rust to infer the different numerical type. The reason the error is Rust cannot compare string and number. Ultimately, you want to convert the string program that reads input into a number type so it can compare it and be so by adding this function body. So basically, when I read it and put the guess, I want the guess. Interesting. Hmm. I don't know how much I like this. So you have this, but then you giving the ownership to this thing. So we create a variable named guess, but wait, doesn't program already have variable named guess? Yes, it does, but hopefully Rust allows us to shadow the previous value of guess with a new one. Shadowing lets you reuse the guess variable name rather than forcing us to create two unique variables, such as guess string, for example. We will cover this more in chapter 3, but for now, we know that this is a feature often used when you want to convert a value to one type to another. We bind a new variable. The guess expression refers to original guess variable that contains an input string, and the trim method on the instant will eliminate any white space. Okay, and then okay, which must be okay. I'm a bit confused. A bit confused. Instant will eliminate any white space at the beginning and the end, which must be able to compare to a U32. A U32, but this is okay. Okay, so what if I don't infer a type? What does this say? Yeah, this is an N32. Interesting. So can I do like U32? Does that work? Yeah, U32, size 4, align 04. I don't know what that means. Oh, okay. So yeah, it can be an I, it can be a U. Well, doesn't matter. I think we can just do like a U8. And it should still do that. Okay. Which can only contain numerous must you press and red line. Edit new line. Well, if you user types 5, and present new line on Windows. Tree method eliminates it, and nothing just 5. Converts it to another type. However, we use to move from a string to a number. We tell Rust exactly type by using let me guess or usually too. Okay, but there's also a mismatch type now. Okay. Uh, you see the good default small positive you learn more about. Additional user annotation is this program. And comparison secrets inferred should be used here. So now chemistry will be between the same type. Method only works. Check the logic convert. Okay, the parse method only works on characters that all can logically convert into numbers, so it can easily occur if number string. So basically, if it's an error, treat it, extract. Okay, result. Mm, okay, so there's an issue that I have here. So this result. Okay, so let's guess. So you're inferring, or not inferring, like you're declaring it's a user D2, and you say that it's guess dot parse dot trim first, I think. That's right. Dot trim dot parse, and then you say expect, and here please enter a number, and you have to close this. However, we have an issue here. I think. Alright, so basically, I'm not inferring this type, right? This is from the extension that shows me, like, you see it's grayed out because it just inferred from this. So if I have this as I32, it will infer this as R32 because it knows I'm comparing it here. But if I don't compare it, so I do that and say this is a U8, there's nothing gonna happen because it doesn't know that we compare it again. So, but if I return the comparison, it will infer that it's user date. Interesting, very interesting. Alright, so what if I do a let guess guess 1 equals u, let's say I8, which is basically a number, and I'm just gonna say this is 0. Oh yeah, actually just an I8, and then I'm just gonna say match yes 1 dot com secret number, so reference secret number. Now I'm just gonna copy all this. Oh, it doesn't break, which is interesting. Can I say this is a mutt? There you go. Alright, so when I say it's a let, oh no man, it is complaining. It's a user to 8. So what if I do this? Does it do anything? It's the user date. Okay, so what if I put this at the bottom and then save? Yeah, okay. So it says it's an I because comparing with guess first, guess one which is an I, and then I see. Okay, that's a good way to do this. It's okay way, like you don't infer a number here, so this you get a hint. So now this becomes a U8 because you know uh, what if I say like 220, like 1000, say 1000. Yeah, problem range for you at literal, yeah, does not fit. 255. Okay, so what if I hear like 216? I think that's a thing. Okay, the error goes away. So if I do another 0, yeah, yeah, okay, I gotcha. So let's turn this to a U8, and the group is to 100, and then compare, and everything looks great. Okay, now let's go run, and I put like 30. It's too small. I can run it. 42. You guess too small. And that's the game. Okay, that's so good. Alright. I don't think I need a user D2 at all. I must look at this with looping. Oh yeah, loops. So loops control flow. Movie word creates an infinite loop. We'll add a loop to give the user more chances to guess. Okay, as you can see, we move everything. I'm gonna get into the four spaces. Each run program will not ask to guess forever, which actually produces a new problem. It doesn't seem they can get to quit. A user can always enter program by going to C, but there's another way to escape, as mentioned, the parts discussed. So if the user enters a non-number answer, it will crash. We can take advantage and allow us to quit as shown. I typing quit to the game, but as you notice, you're entering another input to say least. Game also stops when when the correct number is if you want to finish. So it's saying like if you type quit, okay, it's a string, so it's going to go here, right? And it will break. We should be handling this way more like gracefully. I don't like that because if I go run, like if I say a GT, it's gonna crash, which I don't like that. I'm probably gonna learn like how to handle this without crashing it. But anyways, hold and interrupt the program by using the Mishi key equals you win, and then print line and break. So this will break the loop. Okay. So first of all, we have to add a loop, right? So do 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 do. So mommy need two license loop and so giving me an error somewhere. Alright, so this is the error. It says guess is out of spoke. It's only the body that you we cannot turn. Another to pick out that number. Yeah, so one is gonna be out of scope. And also we need to break here. So this is a new line. I think we need to do this. Yeah, we do that. So right now, guess is not out of scope. Press enter number, failed to read line, whatever. Okay, this is good. But then waiting after the correct this, handling invalid input. Okay. Then bad inputs. Then this home me handling invalid input and then summary. Alright, so but doesn't first take quit. Just so continue until you guess it, but it doesn't let you escape as well, does it? I think we need to improve on this. So basically, it's the final code, and basically, if it's a num, then it's okay. If it's an error, then continue. So continue just to continue the loop, right? So, so we don't want to handle this. If this the input error is probably a system issue, but this is something to be. Alright, so what do we do here? So we add a parse and then we add a colon here. I don't like the syntax like that one, but it's fine, I guess. Okay, if it's a num, So what's a num? Like how do you know it's a num? Is it just like, let's just copy the code and see what happens. And also error. I'll just want to continue. I'm gonna save this. And it says unexpected semicolon. Unexpected semicolon here. Expected a semicolon. Why would you expect a semicolon? The parse. Oh wait. So it's a match. Oh, interesting. This is not. So it's saying it basically match whatever is here. If it returns an okay with the numbers, then return number unless you can. Yeah, let me also like guess. No. So I don't know. Does this work? Oh, unnecessary parentheses. Okay. Okay, so basically if guess equals quit, then break. Guess it's a string that's mutable. But here guess is an 8, so he's guessing okay, so let's if I go run. Okay, so I have a warning says core num is unused. I don't use it. So cool. No, so please, so if I say quit, uh, quit, it doesn't say anything. Interesting. But if I say 67, interesting. Let me put this here. Okay, so if I say like 8, you guessed 8. Okay, if I say quit, so what does like the sprint line of this though? This is not true like a boolean. Okay, here. The formatted string must be okay, so something like this. Okay. So what if I say let is like quit equals to this basically. Okay, so let's see. It's saying the argument format must be uh, so this good. So if quit print then quit. Does that make sense? So if this is true, I'll also like quit like that. And then if I rerun the cargo and then like quit, oh it doesn't do the quit thingy. Break. Okay. I'm just gonna copy this here. Copy one. Quit. Quit to false. Why is it going to false? Not compare. Okay, so compare quit. Uh, Interesting. So what do you want me to do? Yeah, I'll say argument to definition. Uh, to string. Okay. So it's saying I can just go to string. Found, and then I can just do a reference. String. I think I can do this. If ordering equals ordering is an equal, then print line width and then break. Okay. Expected a semicolon. Where would you expect a semicolon? Wait, so I don't need this. I match. If you can just matching then now. So expect a semicolon here. Is it unreachable? Let's try it. This is reachable, so if I match equals to quit. Okay, so let's do. It says here is unreachable statement, but I don't think it is unreachable. I think it's still reachable. So if I say input is quit, uh, I have no idea what I'm doing. Alright, anyways, so let me just do that. And we call it that. So let me do this. And if I say 72, you won and it quits. So yeah. Next tutorial, I have no idea what I'm doing, but I think here control flow will be the one. Tableau covers the concept that appears to almost every program language, how they work, and thus many program languages have much in common. For one of the concept presented in Q&A, I will have discussed the concept and specifically you will learn about variable basic types, functions, comments, and control flow. These are foundations of every first program. Learning them early will give you a strong core foundation. Rust core are a set of keywords that are reserved on language which are another language. Keep in mind, there was really special meaning. Yeah, yeah, yeah. Of course, I'm saying Appendix A. Yeah, so I can't use. Oh, that's interesting. They have like a keyword reserved for feature use, which is where the fire and syntax lets you keywords are normal allowed. You saw by prefixing it based on R tag. Interesting. That's not how I would do that, but it's fine. Uh, Sees. I mentioned this throwing value section by default are around mutable. There's one of many knowledge Rust gives. Your code a way to take advantage of the safety of mutable. Okay. See wires encourage removability, or sometimes you might want to opt out. When a variable is muted, once file is bound to a name, you cannot change it to assert this generate. This is right now run this is receive an error. Okay, the example shows that how compiler helps you find error in program. Compiler error are by facilitating, but really they only mean your program isn't safely doing what it want to do yet. That does not mean that you're not a programming experience. Wow. Wow, wow, wow. It's putting encouragement here because it's not even sure. Okay, you receive an error cannot assign twice to immutable X because try to immutable. It's important that we get compile time errors when we attempt to change the value that is detected as a pupil because this virtuation can lead to bugs. If one part of our code operates on the assumption that the value never changes and the another part that changes, it is possible that the first part of the code won't do what it's trying to do. It's because this kind of bug is difficult to track down. In fact, especially yeah, true. Like using JavaScript with object references is just so not great. So sometimes, I like there was another question that was a recursion question, and I had like a map. And the map is just like a number maps to an object, but when I retrieve the object is the object is returned by reference, not returned by value, which is not what I want. So I had to like do an object assign or like copy, object slice, whatever it's called. I just need to redo it again. Yeah, ability very useful. Can make a move for right. Although variable empty by default. Within the modern front, adding mod also conveys the intended feature. The code indicates the core will be changed. Yeah, it's also like optimizations. I think, for example, if it's not gonna be changed, so just let x equals 5. Like with like compiling optimization, you can just like not do this at all and just like the value of x is 5 without like doing like programming stuff. Just like move this to here. But if it's like a mutable, you have to put like which where is it? So you have to reference like a memory place, I believe. So you don't get the optimization if you let it like mutable. Anyways, I'm bambling, but it must make sense. Like if it's not mutable and it's constant, then you don't need even this line of code like in the compiler step, like after it's compiled, and it just inline it in whatever you want to use it. However, if it's mutable, then you have to reference a part of the memory that contains this variable to know what is the current value of that variable. Makes sense. Cool. For example, yeah, when we run this program, we get this, yeah, which is fine. Constants like immutable value constants are valid constants. are like immutable value constants are values that are bound to a name and are not allowed to change. But there's a few differences between constants and variables. First, you aren't allowed to use mut. With constants aren't just immutable by default, they're always unmutable. You will declare constant using the constant variable instead of the let, and the type of the value must be annotated. They will cover types and annotation. The type of don't worry of details. This can be declared in the scope, including global scope, which makes it useful for values that many parts of the code. The last difference is that constant may set only to a constant expression, not result of value that can be all computed at runtime. Alright, so basically we're saying here that its constant doesn't change, and usually we have capital casing, but also you have to specify the type, and also you cannot have a variable here. So unless the variable here is another const, you can't use a let in this. So for example, you cannot say like let 60, like the word 60 equals the number 60, and just put here the word 60. So that's not gonna work because that's a let, right? Especially if it's somewhat, if it's immutable, then you cannot do that. Anyways, 60 TMC just prevention uses it and the score compatibility value and we just write the value. User time rather than setting constant value serious. Wait. Rather than setting value for more information. The compiler also evaluates the limited set of operation at compile time, which let us choose to write out this value in a way. Oh, so yeah, so basically with this way, like it just computes it at build time and just put it as this number instead of like communicate again every time you want to use it. Constant runtime repeats within scope will declare makes constant use. Sorry, constant are valid for the entire time a program runs within the scope in which they were declared. This makes constant useful by application domain. The reported program domain not such exact same number of points. Any player of a game is allowed to earn a speed of light, naming hard-coded values used throughout your program as a constant. It will convey the meaning that the value to the future maintainer of code. It also helps the only one place you could never. Okay, so basically it's saying as long as it within the scope, so as long as it this brackets, it can be used anywhere, but anywhere within the scope. But if you have like something like this and you put this const here, then it will not be used inside of it. That's what I'm understanding here. Okay, so shadowing, as you saw, oh, in chapter 2, this is a lot of reading. Can declare a variable the same name as previously was shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable in effect. The second compiler overshadows the first one, taking any uses of the variable name to itself until itself is shadowed or scopes end. We can shadow a variable by using the same name variable. I have a hard time understanding this, but what I'm think they're trying to say that this will print like 12 and this will print 6. Yeah, so yeah, because you shadow this and you use it as a let again, so you're not modifying. So if you don't use the let if you oh, this is kind of confusing, not gonna lie. So it's not mutable per se, but it's the same variable, but also it's not the same variable, not the same place in memory, or bit confused. But I guess I get it. So shadowing is a new concept. This is not in any other program, or not many programs, I guess. Yeah. Okay. Yeah. The program first bind x to a value of 5, then it creates a new variable. So it's shadowing the last one, so okay. Then it creates a new variable by repeating let x, taking the original value and adding a 1 to it. Then x is as the value. Then within the inner scope, we create a curly bracket. The third let shadows the x, and x and create a new variable, multiply it by x, and when the scope is over, the inner shadow ends and returns to being 6. That is so confused. So it's not the first thing I did. Oh. Mm. Okay, I get it. I kind of get it. Okay. Shadowing is different from making a variable as a mut because it lets compile it, because we will get if we accidentally try assign this to a variable without using the let keyword. By using let keyword, we can perform a few transformation on the value, but let the value. Okay, shadowing. Keyword again. We change the type. Wow, we changed the type. Is this gonna cause errors? Okay, wait. Oh yeah, you cannot. Interesting. Okay, I'm gonna stop here. I think this is enough content for that. It's just a daily. It's day two. Which I didn't do a lot actually, but yeah, you learn in moderation, right? There's still 20 chapters, but if I feel like I will finish like chapter 4 today. If not, then it's okay. I have other things to do. Bye.